Hi class, this is Sir Alex again. Welcome back to our lesson in General Physics 2. We are finishing our discussion in lesson 4, Superposition Principle. So last time we solved two problems with three charges. The first problem was the three charges are in a straight line. The second problem was the three charges are forming a sort of a triangle. So this time, what we are going to do is we are look at the sample problem wherein we have more than three charges. We are dealing with a situation that we have four charges. So what we're going to do is apply the superposition principle in order to solve for the net force experienced by one of those charges because of the three charges within its system or vicinity. So let's head on and look at our sample problems. Here you go. Okay, so as you can see from the picture, we have four charges now. And our four charges are situated in a way that they're forming a square. So let's look at the sample problem and understand what is happening. Okay, so we have 4-point charges. So there you go. And two of those four charges have a magnitude of 2.5 times 10 raised to negative 6 coulombs, while two of these four charges has a charge of negative 2.5 times 10 raised to negative 6 coulombs. So we can write that as our given. So our first charge has a positive charge and the magnitude is 2.50 times 10 raised to negative 6 coulombs. And our next two charges has a charge of negative. So I'm just writing the negative and the positive sign there to identify or to help us not to get confused what kind of charges we're talking about. But also there's the sign here, so that's negative 250 times 10 raised to negative 6 coulombs. So if you can see in the picture, I'm just going to write them. These are actually our positive charges, and this is our negative charge. So I did not assume this. That's the drawing there. So the Q that you see in the middle there has a negative charge, and the positive charges there are written. They're just a little small, so I just wrote them down so you don't get confused which are the positive charges and which are the negative charges. Okay, so these 4-point charges are situated at the corners of a square. So you can see the charges are at the corner of the square, and the square has a side of 1 meter. So we can write that down as our distance. We have a distance of 1 meter. What that tells us is this square has a side of 1 meter. What that means is that the charges are 1 meter apart from each other. So we have our Q at our side A or corner A, and it is 1 meter apart from this Q found at corner C. The same thing is true for A and B, but of course it's not true for D because this is not 1 meter. But B is 1 meter apart from A and 1 meter apart from QD. So that's what's happening. So we found our distance. So what we are looking for is the resultant force or the net force that the charge at A, so we are looking for, so this is our asked. We're basically looking at the total charge or basically the resultant force that is found at charge Q at corner A. So we are looking for the total charge that QA experiences because of QC, QB, and QD will experience due to the charges at the other corner of the square. So that's what we are looking for. Now let's look at the formula in order for us to be able to solve this problem. First, again, we have to use the Coulomb's law because, again, like what we did from our previous examples, we have to find the forces that these charges C, B, and D, charge Q, charge QB, QC, and QD, do to charge A. So they are exerting a type of force. It's a type of an electric force. So QC exerts a force onto QA, QB exerts a force into QA, and QD exerts a force onto QA. So in order for us to find those individual forces, what we have to do is use the Coulomb's law. Moreover, we also have to find the F total. And we know in order for us to find the F total, we're also going to use this equation right here that we used previously. So Fx squared plus Fy, or the sum of all the charge forces in the x direction and sum of all the forces in the y direction, square those each and then square root them, you will find our F total. And we're going to add another equation, which is an angle equation. Angle is equals to tangent of the absolute value of the sum of all the forces in the y direction over the sum of all the forces in the x direction. This angle right here will actually tell us the direction of our total force. So these are the equations that we are going to use in order for us to solve this problem. So let's begin solving this equation right here. As the same that we did on the previous two sample problems, what we're going to do is first find the individual forces that QC, QD, and QB does to QA. So let's begin with uh, the force that QB exerts on A. And again, in order to do that, we have to use Coulomb's law. D squared, and we just have to plug in the number. So that's 9 times 10 raised to 9 Newton meter squared per coulomb squared. That's our key value. And what we're looking here is the charges, or the absolute value of the charges of QA and QB. And we know that QA and QB are a positive charge of 2.50 times 10 raised to negative 6 coulombs multiplied by another 250. Oh, 250 times 10 raised to negative 6 coulombs divided by the distance between QA and QB is 1 meter, because the side length of a square is the same everywhere, and that's 1 meter. So that's 1 meter squared. So we'll cancel these C's right here. Our M also gets cancelled. So we're gonna multiply these and then divide it by the square of 1 and then multiply it to our K value. And if you just plug in that on your calculator, you would find that the force that QB exerts on A is actually equal to 0.0563 newtons. So that's 0.0563 newtons. And we're gonna do that again, but this time what we're looking for is the force that QC exerts on A. And again, we're going to use the Coulomb's law. We have QA, QC, absolute value divided by D squared. And if you actually look at your values right here, QA and QC, even though QC is negative, we are using the absolute value, so we just have to remove the negative sign. On what you will notice, it's basically the same values as FB on A. 2.50 times 10 raised to negative 6 multiplied by 2.50 times 10 raised to negative 6. Even the D value is the same. So what we'll ended up having for our FC on A is exactly the same value for FB on A, 0.0563 newtons. So now we have our forces on FB and A and FC and A. We're going to look for the force that FB exerts on A. And we're also going to use FA QB divided by D squared. We're also going to use Coulomb's law. But the only difference here now is, if you notice, we have to find the distance between A and B. We have to find this distance. So how are we going to do that? Well, it's actually quite easy. So if we are going to draw a square, there you go. So we know this is our A and this is our D. And we know that the angle of all this of the corners of the square is 90 degrees. If we're looking for the length of this side right here, this DA, D, so the distance between A and D, we're basically going to use Pythagorean theorem. If this is 1 meter, if this is 1 meter, because what we ended up having is actually basically a triangle. So this is our D, this is our A, and that's our 90 degrees. So we're looking for DAD, and we know this is 1 meter, this is 1 meter. In order for us to find this, what we just have to do is take this square it, 1 meter squared, add this side and square it, and square root, add these two, then square root, and you would get that the distance between A and D is actually equal to 1 point, it's a little more than 1.142 meters. So now that we have the distance between A and D, we can use the Coulomb's law to find the value of FD on A. So that's 9 times 10 raised to negative 9 Newton meter squared over C squared. And then the charges of A and D. Again, we're using the absolute value, so that's basically 2.50 times 10 raised to negative 6 coulomb multiplied by 2.50 times 10 raised to negative 6 coulomb divided by the distance between A and D is 1.4142 meter squared. And if you pick that up and just put that on your calculator, you would get that FD and A is equals to 0.0281 newtons. Now we were able to find all the forces that QC, QB, and QD exerts on QA. What we're going to do now is find the F total. And similarly, F total is again, what? Vector sum. And for vector sum, we have to consider the direction. And in order for us to do that, we have to identify the forces, the direction of the forces that QC, QD, and QA exerts on QA. So let's begin again by writing our QA. So this is our QA right here. Let me just fix that up. So we have our QA right here. And we know that QB is here, QC is here, and QD is here. Let's fix this up. QA, and this is QB. There you go. So this is the charges. And we know that this has a positive charge, this has a negative charge, this has a negative charge, and this has a positive charge. Let's move this and move it upward. There you go. Okay, so let's begin with QB. We know that QB and QA has same sign, so it means the force of QB on QA will be in the opposite direction. So the direction of the force would be going this way. So this is your FB on A. Next, what we're looking for is the direction of QC, the force of QC on QA. And we know that QC is negative, QA is positive, that means the force is attractive. So QC would want to pull QA towards itself. Let's shorten this a little bit because they should be the same. There you go. And this is actually our FC on A. That's the direction of the force QC exerts on QA. Next, let's find the direction of QD, the force that QD exerts on QA. And we know that QD is negative, QA is positive, so QA will be attracted to QD. So this is our FD on A. So now we managed to find all the direction of the forces. What we're going to do now Let's remove this. It's kind of like draw a coordinate plane again. So we know that this is the positive y, this is the positive x, this is your negative x, and this is basically your negative y. What we're going to do now is find the resultant force. Let's just move this here. There you go. So let's find the resultant force. How are we going to find the resultant force? Simple, we have to do the component part. Okay, so let's do the component part. I'm gonna write forces here. I'm gonna write horizontal. Let's just fix this. So we're gonna have forces on this side. We're gonna have the horizontal, and we're gonna have the vertical. Okay, so let's first look at the force. Again, remember, horizontal is talking about the direction of the forces in the x-axis, so that's F cosine angle. And for vertical, that's the direction of the forces in the y-axis, that's F sine theta. Okay, let's look at our FB on A. We know that FB on A is equals to 0.0563 newtons. And what we're going to do is look at the direction of our FB on A. Luckily, if you notice, our FB on A is laying flat in the direction of the negative x-axis. So what that means is it doesn't have a direction going in the y direction because again it's directly in the negative x-axis. So what that tells us is our Fy is actually 0. But if we are going to compute, let's find the angle here. The angle here we know is actually 180 degree. So if we solve for our Fx is equals to 0.0563 cosine 180 degree. Cosine 180 degree is actually negative 1. So negative 1 multiplied by 0.0563 is actually equal to negative 0.0563 newtons. So our Fx, or the direction or the magnitude of our FB and A in the x direction, is equals to negative 0.0563 newtons. So the negative sign is there because it's going in the negative x direction. So let's write this here. Next, let's write Fy. So what would be Fy? Same thing. Take the magnitude of FB and A. It's 0.0563 newtons sine 180 degree. So let's just move this a little downward. There you go. Sine 180 degree. And interestingly, if you look at the value of sine 180 degree, it's actually 0. Sine 180 degrees is 0 multiplied by 0.0563 newtons. That will tell you that Fy is 0 newtons. And that makes sense because we don't have a direction for our FB on A in the y direction. It's all in the x axis. So that's 0. Now let's look at FC on A. Our FC on A also has a magnitude of 0.0563 newtons. Let's solve for our Fx. If you look at our FCNA, you will notice that it's laying flat in the direction of the negative y-axis. What that tells us is that we don't have a direction in the x-axis. So it's all in the y-axis. And even if we solve it, so that's 90, 180, 270. If you actually look for 0.563, if you look for cosine 270 degrees, that's actually 0. Cosine 270 degrees, or cosine is actually equivalent to cosine 90 as well. That's 0. 0 multiplied by 0.0563 newtons, which is the magnitude of FCNA, it will give you 0. And that makes sense because we don't have a direction in the x-axis. Okay? Now if we solve for Fy, which is 0.0563 newtons, sine 270 degrees. 270 degrees is the degree here, so that's 90, 90, 90, 9, 18, 27. That's 270 degrees. It will actually give you sine 270 degree is negative 1. So negative 1 multiplied by 0.0563, it will give you negative 0.0563 newtons. And this makes sense that this should be negative because it's going directly in the negative x or negative y direction. So we managed to find the components for our FB on A and FC on A. Now let's try to find the components of our FD on A. We know that our FD on A is 0.0281 newtons. 281 newtons. And if you look here, unfortunately for us, it's not directly in any of the axes. What that tells us, we have to find the components in the x direction, and we have to find its component in the y direction. And as you can see, our fx is going in the positive x direction. Our fy is going in the negative y direction. And that also gives you a clue that our fx should be positive and our fy should be negative. And what we also need is we have to find an angle. We have to find the angle here. How are we going to do that? Well, let's go back to our triangle here. We know that this is a 90 angle degree. And the same thing here, this is a 90 angle degree. Which means if we cut this off, this gives us a half of the 90 degrees. So this tells us that this should be 45 degrees Celsius. I hope that's understood. Again, this is because this is a 90 degree. That's all 90 degree because they're all in a corner. And if we're going to cut this in half, that would give us half the angle here. So 90 divided by 2 is 45. So this is 45 degree angle. This is a 45 degree angle. So this is a 45 degree angle. Since this is a 45 degree angle and the total here is 90, so it's basically 90 minus 45. And this will tells us that this is a 45 degree angle. So we have to use 45 degrees. Okay, so what we're going to do is we know that our fx is in the positive direction. Fx is equals to 0.0281 newtons cosine 45 degrees. So if you solve this, you would get a value and just add positive because our fx is in the positive x direction. And this is actually equal to 0.0199 newtons. Okay, so now let's just, there you go. Now let's look for our fy. Interestingly, our fy should be negative. The reason for that is because the direction of our FD on A is going in the negative y direction. That's the component. So we just have to use the magnitude of our FD on A, that's 0.0281 newtons, multiplied by sine 45 degrees. After getting that, just add negative sign. Again, it's because the direction of Fy is in the negative. So this is actually equals to negative 0.0199 newtons. After getting all of that, we just have to sum everything Fx. So negative 0.0563 newtons plus 0 plus 0.0199 newtons. And this is actually equal to negative 0.0364 newtons. Next, we're going to do the same thing. 0 plus negative, so the sum of all Fy, 0 plus negative 0.0563 newtons plus negative 0.0199 newtons. This tells us that our Fy is negative 0.0762 newtons. So this is the value of our component in the x direction and in the y direction, meaning our F total is going towards the negative x direction and towards the negative y direction. That means that our fx is around this area. This is our f total. This is the direction of our f total. And why is it here? It's because it should be going in the negative x direction, and it should be going in the negative y direction. So we have our x direction here, negative fx. This is for total. And we have our negative fy for total. There you go. So now we just have to find this. How are we going to find this f total? As you can see, if we create the components, the fx and the fy, we are creating a right angle. That's why if we find f total, we just have to use Pythagorean theorem. I hope this is making sense now why we are using Pythagorean theorem. It's because if you place these components and then you would actually basically going to make a right triangle. So that's fy squared, and if you plug in the values, so that's 0, negative 0.0364 newtons squared, this is newtons, plus negative 0.0762 newtons squared, you would get that the F total is actually equals to 0.08 newtons. But we're not done yet. We have to find this direction. And in order for us to find the direction here, what we just have to do is use our angle equation. That's a tangent. So remember your trigonometry. In order to find the angle here, what I just have to do is divide. Tangent is TOA, opposite over adjacent. So if this is our angle, we have to take the opposite, which is Fy, and just use the absolute value. You do not need to use the negative sign. And divided by TOA is opposite divided by adjacent. Our adjacent is Fx, so that would be Fx. So this would give us arc tangent. Fy is 0. No need for negative. We're using the absolute value, 0.0364 newtons divided by 0.0762 newtons. And this is actually equals to 64.47 degrees. So our F total is 0.08 newtons at 64.47 degrees from negative x. There you have it. So that is our total and the direction of our total. 0.08 newtons is the magnitude with an angle of 64.47 from negative x. That is the direction. Okay, so I hope that is clear on what we did. There's a lot of things that you have to do. So if there are some things that are unclear, please do not hesitate to message me. May you guys have a great day and thank you so much.